subscribe. Hello, this is the North America Math Contest Go Go Go. For this week, please subscribe. Click the subscribe button and the like button or dislike button if you think this video is good. So for this week and the coming few weeks, we are going to talk about calculus. It is a complete go-through of calculus. Yes. So I'm going to try it. So, well, calculus is calculus. Okay, calculus. It is invented by Leibniz and Newton. We can say that both invented calculus. The differences between calculus and pre-calculus and the previous mathematics grades is that calculus, it involves a complete new way of thinking with the limit, the new concept of limit. We can say that limit makes calculus completely different from pre-calculus because it just changed the way how we think about mathematics. So we are going to talk about for some like small things before we start the calculus. The first thing is transformation of function. It is in the first chapter of the pre-calculus. So there are several ways, there are several important transformation. First is this, second is this, third is this, fourth is this, and fifth is this. You can think this as reflecting over the x-axis. And you can think this as reflecting over the y-axis. For fx plus a, it is just you move the entire grid, the entire function right a unit. And if a is negative, then it's left a unit. Fx plus a. So this means it is vertically moving. It is vertically going up a unit. So this is stretching. It is that it stretch vertically for every grid. Or you can think as every y is timed by a in this case. So it's that this is vertically stretching for a times for every for every value. And this is horizontally stretching. We can think about this. If a is equals to 2, then it is horizontally stretching by 2. So those are the basic transformation knowledge. We can do an example to see. Okay. Approximately, okay. So, give an example. Fx is equals to this. So it has a graph like this. It is required you to find fx plus 3 minus 2. So we can just increase 3 units up and we go left 2. In this case, this will be the final answer. So 0, 3 will be the final answer in this case. The next thing that requires is the denotation of functions. So this means if we are given this, it is equals to this. Well, remember, it is denoted. This is not O. Remember, this is not O. Don't think this as a fog. Okay, we are going to give an example. So we get fx is equals to 2x plus 4, while gx is equals to 3x plus 6. So fgx is f3x plus 6, which is equals to 2 3x plus 6 plus 4, which is 6x plus 16. So this is what the notion is. Well, this also, it is also, like some people, they also will write it in this way. Okay, the last thing is the inverse function. Inverse function is every pair of x, y is turned into this. Okay. Every pair of this is turned into this, so you just can think it in the brain. So it is a way about how to rewrite the write the inverse function of a function. Okay. Let's given a function this. So it is required you to find the inverse function of this. The first step is you are going to write in the form of this. The second step is you are going to find x. Rewrite x in the terms of y. X is equals to y minus 1, this. And the last step you are going to do is you do the function into this, and you change y into x, and you are done. So this is going to be the final inverse function. Okay, so now let's talk about the limit. Finally, we get to the limit. So, I think you have heard about a problem. Let's suppose there is, okay, so there's a cake. You eat one half of the rest every day. So the first day you eat this. The second day you eat 1/4. The third day you eat 1/8. The fourth day you eat 1/16, and the fifth day you eat 1/32. So it is required. So you know that every day you eat half of the rest of the cake, which in fact you cannot, mathematically you cannot eat the entire cake. It will always leave a piece that is infinitely small. Even though physically you cannot see it ultimately. So we can say that this gets a limit of 1. Like it is infinitely close to something. So this is limit. It is just something that is infinitely close to something. To a number. You guys think about it. Like this way. Okay, so this is limit, and we are going to talk about two-sided. So a limit. we can think about it in a function. So we are going to talk about limit in a function. Given the following graph, I'm going to just draw a graph. So it's 1, 2, 3, 1, 2, 3. So when it is infinitely close to 1, so it will ask you what is the limit of it when it is infinitely close to 1. Okay, I give you 10 seconds to think about it. Okay, 10 seconds is off. So when it is infinitely close to 1, when it is infinitely close to x equals to 1, the infinite value of it will be 1. Because you see, based on the function, it is getting really, really close to 1. Let's ask you. Then I'm going to ask you again, what is the limit when it is infinitely approaches to this? Well, the answer is clear, which is the y value here. 3.5 or 3.6 something. So this is how the limit thing works on a graph. Okay, so we are going to talk about one-sided limit. A one-sided limit is a limit that is starting from the left side or right side. Okay, it may seem confusing. Let's give an example. Give you a function. Well, this is on the same x-axis. Remember, on the same axis. Okay. So we're given a function like this. Let's see, like they are on the same x-axis with x is equals to 4 here. So we say that this type of limit is not, this limit, it has a left side limit, which is like this. It will have a right side limit, which is like that. So right side limit is it starting from right and is approaching to here. The left side limit is it starting on left and is approaching here. And in some cases, the left side limit has to be identical with the right side limit to make the limit exist. So which means this must equals to this in order to make it exist. In order to make that limit exist. If this is not equal to this, then it doesn't exist. So we can see this is an example that makes the limit does not exist. Why? It is because you can see that 4 minus here and 4 plus here, they have different y-axis. So this means that this limit just doesn't exist at all. How do we express limit? We express limit through this way. Lim. This is the name of limit, and this is x to a. So this means does not exist. Okay, so here we come to the end of this video. I hope you have fun in this video. I hope you have learned things in this video. And see you next week. Subscribe below.